Yes, we have discussed in the previous class about the phasor representation of narrowband FM and as well as the standard AM, right? Yes or no?
Yes,
Yes.
sir.
So just I think you can have a look. I said how can we express e power j theta in terms of cosine and sine, right? I said e power j theta will be equal to cos theta plus j sine theta. And how do we represent that in real and imaginary axis, right? With respect to that, then I replaced theta by 2 pi ft, and I said how can we write e power j 2 pi ft in terms of cosine and sine, right? I said this is the real part of e power j 2 pi ft, and this one is the imaginary part, right? So keeping that in mind, then we know cos theta is equal to what? E power j theta plus e power minus j theta by 2, right? So I replaced theta by 2 pi ft and I substituted, and I found what is cos of 2 pi ft, which is equal to e power j 2 pi ft plus e power minus j 2 pi ft by 2, right? So how do we represent that in the phasor diagram, right? I said e power j 2 pi ft will be rotating in the counterclockwise direction, right? So that we call it as a positive frequency, and e power minus j 2 pi ft will be rotating in the clockwise direction, right? So with this basic knowledge, uh, by writing the expression of narrow, first I think I discussed about AM, right? So we wrote the expression for AM. Then we have expressed that in terms of complex exponentials, right? So real part of this cos of 2 pi fct will be what? E power j 2 pi fct. Since amplitude is AC, I written AC. Similarly, for this also we can write what? E power j 2 pi of fc plus fm into t, right? With this magnitude mu into AC by 2. Similarly, for the third term, I can write mu into AC by 2 e power uh, what? J 2 pi of fc minus fm into t, right? So I took e power j 2 pi fct into AC as common among these three terms. So I segregated that, and I written the simplified form of that, right? So now I can express this. I can write the phasor diagram for this acid, right? Whatever the term I have written in the square bracket. So keeping the carrier as reference, right? So with respect to this point, for the first term, e power j 2 pi fmt will be rotating in the counterclockwise direction, right? The second term is what? E power minus j 2 pi fmt, that will be rotating in the clockwise direction. And this will be my resultant of the side bands, right? So this is the phasor diagram what I wrote for standard AM. Then uh, we know what is the expression for single to narrowband FM signal, right? So that is AC cosine of 2 pi fct minus beta into AC by 2 cosine 2 pi of fc minus fm of t, then plus beta into AC by 2 cos 2 pi of fc plus fm of t. I have expressed this in the again complex exponential forms, right? Same thing. Cosine of 2 pi fct can be written as e power j 2 pi fct, and this also and this also, right? I took AC into e power j 2 pi fct as common outside, then rest of the terms I have written. So here, yeah, this is the phasor diagram I wrote for the narrowband FM. Okay, so I think till this we have discussed it in the last class. So is it possible to just draw some conclusion about these two diagrams? I want quick answer from you people. Yes, can I expect any summary after going through this uh, the phasor representation of these two diagrams? I think anyone can sum up. Just I will write this is figure 2. What it is? Phasor diagram for single tone narrowband FM. Yes, 1 minute time I will give. Yes, what is the conclusion you can draw?
Sir, in AM, the resultant is same phase. In FM, it's out of phase.
Yeah, in AM. Can you repeat?
Resultant is same phase as carrier.
Prithvi, right? You are Prithvi, right?
Yeah.
Yeah. Tell me.
Sir, in AM wave, it's the resultant is the same phase as the carrier.
Yeah, very good. Very good notice. Okay. So that is what the understanding you should be able to get. Right? In standard AM, what we observe is the resultant of the phases corresponding to the two side bands. Right? What is that? I think we'll just go back. Right? Yeah, this one, right? This is the resultant I said. So this is in phase with the carrier phasor, right? So this is my carrier phase. So this resultant of the two side bands is in phase with the carrier phase. Okay. So because of this, we say the resultant of the AM phasor will have an amplitude different from what? The carrier phasor, right? So we all know in the AM, the amplitude of the carrier is varied, right? In accordance with the message signal, right? But in case of FM, what we are observing here, the resultant of the two side bands, right, is perpendicular to the carrier phasor, right? So it is out of phase with this carrier phasor, and the resultant of this FM signal, okay, its amplitude is same as that of the carrier, okay. So this is what the difference is. So in case of narrowband FM, what I said, the resultant of the phases corresponding to these two side bands, right, is perpendicular to the carrier phasor, and here the narrowband FM phasor, this is a phasor, right? Narrowband FM phasor has approximately the same amplitude, right, as the carrier phasor, okay, but it is out of phase with, right? Yes, is this clear? That is why we say in FM the envelope of the modulated signal is constant. Okay. So with this, I think let us take up the next one, that is wideband FM. Okay. So the second one is what? Wideband frequency modulation. Yes, Abhishek Reddy. Abhishek Reddy.
Yes, sir.
Yeah, can you tell me the expression for FM when we consider M of t is a sinusoidal signal? When M of t, okay, I said when M of t is a sinusoidal signal, that is M of t is equal to AM cosine of 2 pi FMT. Okay, when this is the message signal, so what is the expression for FM signal? Yes, quickly you should tell. What is the expressions I can write for FM? Yes, Abhishek Reddy. Are you aware or not?
No. Sir, I don't.
Huh? So
Sir, I
when
don't
m of
know.
t is am cos of 2 pi fmt, so you are not aware what is the expression we can write for fm signal? Not confident?
No, sir.
Just say yes or no.
No, sir.
You don't know how to express FM signal, right? Okay. Yes, so what about Tipana?
Yes, sir.
Yeah, what is the expression you can write for FM signal, man, when m of t is sinusoidal message signal?
Sir, AC cos 2 pi FCT.
1 minute, I will write.
Yes, sir.
Yeah, S of t, right? Yeah, which is equal to what we can write AC,
Cos
yeah, cos of
2 pi FCT
S2 pi FCT,
plus beta
yeah, plus beta,
sin 2 pi FMT.
yeah,
Yes, sir.
sine 2 pi FMT, right? So this already we have discussed many times, right? So this is the expression for FM signal when m of t is a sinusoidal signal. Okay. Yeah. Let me express this. Okay, in terms of the complex exponential. Okay. So I said no cos theta, which is equal to what I can write, that is e power j theta. That is equal to cos theta plus j sin theta. I said. So the real part is what? Cos theta, right? So how do I express this in terms of the complex exponential? Uh, yes, Leah, can you say? Leah? Yes, Leah is there. So Leah is not speaking. Okay, whatever Shreyas. Shreyas MP.
Yes, sir.
Yeah. How do we express that AC cosine of something we have written, an expression for FM in terms of complex exponential? So you can treat this 2 pi FCT plus beta into sine 2 pi FMT as theta. Okay, it is as good as AC cos theta is there, right? If you treat entire the thing which is there in the square bracket as theta, how can I express that in terms of the complex exponential form? Yes, just now I revised it. No, e power j theta is equal to what I wrote. Cos theta
Sir,
is sin theta. No, cos theta is a real part. I
yes,
was
sir. E power j theta plus e power minus j theta by 2.
fine, man. Here, what is theta? If you tell the value of theta, no. No, in that only the real part. What I say, so I can write this as AC. Okay, real portion of this is I can write e power j. Okay, either I can write a single term as 2 pi fct plus beta into sine 2 pi fmt, or I can write it as two separate terms. That is e power j 2 pi fct. Okay, into e power j beta into sine 2 pi fmt. Okay, so let me call this as equation 1. So what is wideband FM? When beta is much greater than 1, right? We call that as a wideband FM, right? So I'm expressing that the FM equation in terms of the complex exponential form. Okay. So here the second term, that is e power j beta sine of 2 pi fmt is a periodic signal with period equal to 1 by fm. Okay. So what I said, the second exponential term, what is the second exponential term? Yes, what is the second exponential term I have written? Anand? Anand.
Yes, sir.
Yeah. See, I could express AC cos of something in terms of exponential form. Okay. In that, I said the second term is what? What is the second
Yes, sir.
term? Man? If I take this as first term, okay, and this exponential as second term. Okay. So I was telling e power j beta sine 2 pi fmt is a periodic signal with period is equal to 1 by fm. So we can write the term e power j beta sine 2 pi fmt, okay, is periodic with period equal to 1 by fm. Okay. So you all aware how to express a periodic signal by using complex Fourier series? Yes, you know how to express a periodic signal using complex Fourier series. Anyone can say? Or I will ask some people. So Leah is not at all talking, right? So she is not there. Yes, Bharti. Bharti.
Sir, I think it's the G of T expression, no, sir.
GFT only, yeah, tell.
G of T equals sigma n equal to minus infinity to infinity fn e power j n omega naught t.
Yeah. So, as I said, this e power j beta sine 2 by fmt is a periodic signal, right? With period equal to 1 by fm. So, it can be represented by a complex Fourier series. Let me write that. Hence, it can be represented by a complex Fourier series. Okay. If I consider the periodic signal as g of t, okay, so let me write a periodic signal if I consider g of t is a periodic signal, and this can be expressed in complex Fourier series as a complex Fourier series Okay. And it is given by and g of t is equal to summation n is equal to minus into infinity fn into e power j n omega naught t. Okay. So let me call this as equation 2. So I can express a periodic signal by a complex Fourier series in this fashion, that is summation n equal to minus into infinity fn into e power jn omega naught t. Right? So what is this fn is called? Yes, what is fn?
For Fourier coefficient.
Yeah, it is a Fourier coefficient, right? So fn I can write where fn is the complex fn is the complex Fourier coefficient. So how do we define that? Anyone can say how do we define the Fourier coefficient? Yes, what is the formula for that? Yes, Akshay Kumar, can you say? Akshay Kumar.
Yes, sir.
Yeah, how do we define the Fourier coefficient, complex Fourier coefficient? Yes?
I don't know, sir.
You don't know. Okay. If you are not aware of this complex Fourier series and other things. Yes, anybody from the class? Nobody knows? How do you define the Fourier coefficient? Yes,
Sir,
what
it's
about
1 by 2L or something after that.
Yeah, 1 by
2L.
So these are the basic things which you have learned in mathematics, even in other subjects also. Okay. See, the complex Fourier coefficient Fn is defined as Fn, which is equal to 1 by t integral from minus t by 2 to t by 2 into g of t into e power minus jn omega naught t into dt. So this is the definition of Fourier coefficient. So let me call this as equation 3. Okay. So now, this is the general what I said, g of t, and how do I define the Fourier coefficient and all. So now let me try to apply this to our present context. What is our present context? Which one I said is a periodic signal? Yes, with our present context means with respect to wideband FM, what is a periodic signal?
G of t.
G of t is a general thing I have taken. And if G of t is a periodic signal, okay, how do I express that in terms of complex Fourier series I have written? Then I have defined what is complex Fourier coefficient. I need to apply this to my signal. What is my signal? I expressed this wideband FM, that is FM signal in terms of complex exponentials, right? In terms of what? AC real part of e power j 2 pi fct into e power j beta sine 2 pi fmt, right? In that, which one is periodic? I said the second term, right? I need to apply this periodicity for the second term, that is e power j beta sine 2 pi fmt. Okay, so let us try to do that. I hope you people have noted these equations. So now let me set g of t. Okay, g of t let g of t is equal to what I can write? E power j beta sine 2 pi fmt. Okay, right? So with respect to this, what I can write, omega naught will be equal to what? Yes, what will be omega naught?
2 pi FM.
Yeah, 2 pi fm, right? And what is t?
1 by FM.
1 by fm. T is 1 by fm. So now let me substitute this in that. So e power j beta sine 2 pi fmt is my g of t, right? So it can be written as what? In terms of complex exponential series, summation n equal to minus infinity to plus infinity, right? Fn into e power j 2 pi fm n into t. Yes, is this fine? Just I substituted g of t in that equation, that's all. Okay, so let me call this as equation 4. Yes, any doubts so far? Yes, do you have any
No,
doubts?
sir.
Just shall I scroll up and write? So I hope you are all with me. So now let me define what is Fn. How do I define Fm? Yes, Fourier coefficient, Fn. Yes, what will be Fn? 1 by t, right? What is t?
1 by FM.
Yeah, 1 by Fm. 1 by Fm, then integral, right? See, minus 1 by t, right? That is what I can write here. 1 by 2 Fm, right? 2
Yes, sir. 1 by 2.
2 Fm, right? Then what is g of t? G of t is that e power j beta, right? Sine 2 pi fmt, right? So we write the next term. That is what? E power minus j 2 pi fm nt into dt. Okay. So let me call this as equation 5. So just I have written what is Fn. Okay. So now Yes, is it noted? Shall I scroll up?
Yes, sir.
Yeah. Now, by letting what is that? 2 pi FMT is equal to x. Okay, 2 pi FMT is equal to x. So, what I can rewrite equation 5 as? Yes. Yes, what I can write? By letting 2 pi FMT is equal to x. This is equal to what? Yes, 1 by 1 by Fm will be equal to what? I can write Fm, no? Yes, shall I write Fm or not?
Yes, sir.
Then integral, what are the limits now? Yes, what are the limits? Then what is inside the integral? See, this one 2 pi FMT will be equal to what? X, right? I can replace this by x, right? Yes or no?
Yes, sir.
E power
Yes, sir.
j beta x I can write as a first term, right? Then what is the next term? Here 2 pi FMT.
Sir, J beta sin x, no, sir?
J beta sin x. Correct. Because 2 pi FMT is my x, right? So J beta sin x, right? Yeah, what is the next term? What is the next term I can write? E power minus j 2 pi fm nt is there. 2 pi fm t is x. What can I write for that?
e power minus jx and t.
E power minus j n x, no?
xt.
No t. See, 2 pi fm t is equal to my x.
Only x.
Yeah. I'm taking 2 pi fm t is equal to x, right? So what is dt? What I can express for dt?
Tx.
Yes. What is it? See, 2 pi fmt is equal to x. You can't say what is the expression for dt with this.
dx by 2 pi fm.
Yeah, dx divided by 2 pi fm. Right? 2 pi fm. Yeah, tell me the limits. Yes, what are the limits? Integral limits we are not telling.
Minus pi x by t to pi x by t.
Yeah, it is minus pi to plus pi.
Sir, it's minus pi x, right? Minus pi x by t.
Yeah, 2 pi fmt is equal to x, I said, right?
Yeah.
Just think 1 by 2 fm, right? And here I have written dx is equal to 1 by 2 pi fm. That is dt. It's very basic. Yes, this can be written as what? See, this FM will get cancelled now. I can write this as 1 by 2 pi, right? Integral from minus pi to pi. Then what I can write here? E power, if I take j as common, then what is left out here? Beta, right? sin x, then minus nx na, this into dx. So I cancel this by fm and fm. Okay. So this is in what form? I have come across anywhere, anytime this type of expression. Yes, I am asking you people only. I have come across anywhere, any place, this type of this. So this we call as Jn of beta. So this is what? This is the Bessel function of first kind and nth order. Okay, with the argument beta. Okay. So I can write Fn is equal to Jn beta. So let me call this as equation. How much it is? 6. Right? So what I said it is 1 by 2 pi integral from minus pi to pi j of beta sin x minus nx into dx will be written as what? Yes, are you aware of Bessel functions or not?
Sir, can you scroll on top?
Yes. So I said Jn of beta is the what? Bessel function where Jn of beta is what? Yes, you have not come across anywhere about the Bessel's function. Yes, anywhere you studied or not, man, Bessel function. Bessel function, I'm asking. No answer.
No, sir.
You have not studied anywhere Bessel function. You have studied in mathematics, man, I know.
Don't remember. Sir.
Sir, also I can say. Huh?
You don't remember, I guess.
Ah, you
No,
don't
sir,
remember.
actually, I have not studied this.
Only teacher should remember. Why students should remember? Na? What you will get if you remember? But if teacher remembers, he can continue his class. Na? Right? As a student, you don't have to remember. And everything should come from air. Okay? So this is very fundamental mathematics, Bessel function. Okay? I am saying this Jn of beta is the Bessel function of what? First kind and nth order with argument beta. So that is what, see, higher semester subjects, to understand, you should know the fundamentals properly. So do you think that am I saying anything new? I'm applying the concepts of basic mathematics. Whatever I'm doing is very basics. Complex exponential series, that's all. You people don't know how to express a periodic signal, right? By using a complex Fourier series, and you don't know how to define the Fourier coefficient also. What is everything? Now only you need to recall, even you are not able to recall also. So not aware of then Bessel function, just have a look now. Go back and see, because I cannot spend much time on that now. I need to use of that. Okay, how do I use this Bessel function in my wideband FM representation? Okay, so now let me substitute the value of what Fn in which equation? Where can I express this? I need this value. Yes, where I have written g of t, that is e power j beta sine 2 by fmt is equal to, where I have written summation n equal to minus into infinity fn into e power j 2 by fmt. There I need to substitute, no? So what is that equation number is?
So 2.
No, not 2. E power j beta sine 2 by fmt is equal to, I wrote summation n equal to minus into infinity fn e power j 2 by fm nt.
4, sir. 4.
4, sir.
Equation 4. So substitute the value of Fn as Jn of beta in equation 4. Okay. So what I can write equation 4. Yes, you can't say substituting just the Fn as Jn of beta. So substitute equation 6, okay, in equation 4. So we can write e power j beta sine 2 pi fmt, right, which is equal to what I can write summation n equal to minus into infinity, then jn of beta, okay, into e power j 2 pi fm n into t. Okay, so let me call this as equation 7. So now where I need to substitute the value of this e power j beta sine 2 pi fmt, in which equation I need to substitute to say this is the expression for wideband FM. Yes, quickly people should say.
1, sir.
Yeah, in equation 1. So substitute equation 7 in equation 1. Substitute equation 7 in equation 1. So what we get? Yes, what can we write? Yes, what can you write the expression for SFM of T? AC, I said real part, right? What is the first term? First term is e power j2 pi fct. So we are writing as it is, right? So what is the second term? Second term is e power j beta sine 2 pi fmt, right? So for that now I need to substitute in place of e power j beta sine 2 pi fmt as what? Summation n is equal to minus infinity to infinity, right, jn of beta into e power j 2 pi fm nt, right? So now I can rewrite this. Okay. I can take this e power j 2 pi fct inside. Okay. So AC real part of summation n equal to minus infinity to infinity jn of beta is what I can write when I take e power j 2 pi fct inside e power j, right, 2 pi of fc, right, plus n into fm of t. Is this fine? Yes, I'm asking, is this fine? Just I multiplied e power j 2 pi fct inside the summation box. Okay, so e power j 2 pi fct into e power j 2 pi fm nt. So powers are added. So I took e power at j 2 pi outside. So I am writing fc plus n fm t. Okay. So now, what can we write the real part of that, right? Yeah. Yes. E power j theta. What will be the real part of that? Hello. See, e power j theta is equal to cos theta plus j sin theta. Right? So e power j theta, real part of that is cos theta, right? So I can write this as AC, okay, summation n equal to minus into infinity, okay, jn of beta into cos of, is cos of what?
2 pi
2 pi
fc plus NF.
fc plus n fm of t. Okay. So this is the expression for wideband FM. Yes, anyone can say in what way this is different when compared to the narrowband FM, this expression? Yes, looking at the expression. Let me call this equation as 8. Yes, I hope you are aware of what are the properties of the Bessel function. If you don't know what is Bessel function, now you will be able to know the properties of Bessel function, right? Fine. So I will come back to that. Just to say, see here cos of 2 pi of fc plus n into fm, right? So this indicates what? In the previous case, in case of narrowband FM, right? So we have only one pair of sideband. Here, fc plus n into fm. Just think about this, n into fm. The value of n varies from minus infinity to plus infinity. Means what? We'll be getting fc plus fm, right? Then fc minus fm. Means if you keep substituting the value of n as plus or minus 1, what you will get? We'll be getting fc plus fm as one component, then fc minus fm as another component, right? Then when n is equal to plus or minus 2, we'll be getting cos of fc plus 2fm as one component, then fc minus 2fm as another component. Like that, it will have infinite number of sidebands, right? So the wideband frequency modulated signal has infinite number of sidebands. But in case of narrowband FM, what we say, it has only one pair of sidebands, that is upper sideband and the lower sideband. So after understanding what are the properties of this Bessel function of first kind and nth order, okay, so we will be able to appreciate the importance of this equation, and how do we say it has n number of sidebands, that is infinite number of sidebands, and what is the bandwidth required for transmitting such a wideband signal. Okay, so is this clear, or do you have any doubts about this arriving to this equation? And we'll write the expression in terms of frequency domain also. Just take the Fourier transform of this, we'll be able to express in terms of in frequency domain. Okay, so let us write that also. So take Fourier transform to equation 8. Yes, what can we write? Yes, what is the Fourier transform of this? S of f, right? For wideband FM, which is equal to, see, the first term will be as it is, and Jn of beta summation will be as it is. What is the Fourier transform of cos of 2 pi of fc plus nfm of t? Yes, what is the Fourier transform cos 2 pi fct? Just assume that the complete thing is fc. Here it is fc plus nfm is that. Yes, Srujan, can you say? Srujan. Yes, I'm asking Srujan. No, Srujan.
Yes, sir.
Yes. Tell now, what is the Fourier transform of cos 2 pi fct? Yes? Yes, is it correct? AC by 2 summation I am writing n equal to minus infinity Jn of beta, right? Jn of beta del of f minus of this, right? Another one is f del of f plus of this term, right? So del of f minus of this term is what we'll get? Fc minus nfm, right? Then plus del of f plus that term fc plus nfm. Okay, so let me call this as equation 9. Yes, is this clear? The expression for the Fourier transform of equation 8. Yes, do you have any doubts? Just I have written the Fourier transform of cos 2 pi of what? Fc plus n fm of t as what? Del of f minus of the term, that is Fc minus nfm, then plus del f plus of that one Fc plus nfm, right? So by substituting the value of n from minus into plus infinity, you will be able to draw the spectrum of the wideband FM. So let us see the properties of few Bessel functions, I think, in the next class. Okay. So with this, I will stop.